Okay, so we broke this into 2 weeks because when Dr. Gu asked me to do a webinar on green roofs, I told her there's no way I can do it justice in 1 week. So I kind of split it into design and installation, and then next week we'll talk about maintenance approaches, and we'll get into a little bit of the nitty-gritty, what makes a plant good for a green roof type discussion. And so just to get started with green roof designs here, we need to talk about the benefits. Now, I'm not going to get into the research of each one of these because I could literally spend a week on each, and in my course I do. So I'm going to give you a quick rundown. The biggie is stormwater management. So if you're coming to us from any kind of an urban area, green roofs are probably utilized in your area for stormwater management. Now, that can mean quality, quantity, or both. We know now that in terms of water quantity, most green roofs are going to hold about 1 inch of rainwater. Now, that's a very broad generalization. It can depend on when was the last time it rained, so how much water is already in the system. To an extent, it can matter how deep the substrate is, but what we really know now is there is not a direct correlation between deeper substrate and more stormwater management. If there was, every building would have 12 inches of green roof on it, and we would not have any stormwater problems in cities. And since that's not the case, we know that we can't do that way. The problem is with quality. Thanks to Dr. Elizabeth Fassman Beck's work that started in Auckland, and she's now at Stevens Institute in New Jersey, she has done so much work poring over the literature, and she has told us now that we are sure green roofs load nutrients, both nitrate, nitrogen, and various forms of phosphorus. So if you're in a watershed, or if you're in an area where nitrogen and phosphorus loading into natural waterways is a problem, green roofs may not be best for you, because we contribute like whoa with green roofs. It's pretty scary how much we're offloading into our discharge. Increased biodiversity. It's kind of common sense. If you put vegetation on a rooftop where there wasn't vegetation before, you're going to have some biodiversity. That bee on that plant, that's one of my research plots for my dissertation. Based on what unit of measure. This is not good or bad. I just want you to know, if you're reading a research report about increased biodiversity with green roofs, read between the lines, read the materials and methods closely, and find out, are they comparing rooftop to rooftop, or are they comparing rooftop to ground below the building? And there is not a right or wrong way to do it. You just need to know what you're reading when you're reading it, because there are various methods of doing the work. Increased energy efficiency. This is a biggie, especially in Texas. The Texas green roof industry is starting to grow. I'm starting to see more and more green roofs going on. We have a massive one going on a brand new building here on campus. There's 3 others that I'm aware of now. Here it's about energy efficiency. It is so hot here, and we use so much air conditioning. The catch is, it depends on the season how efficient you're being. So DJ Saylor did a study, he did a modeling study actually, using a model that was already used by the Department of Energy. He published those results in 2008, and I want to remember that I think that journal was called Building and Energy. I'd have to pull the actual paper. But what he did was he ran through simulations using a model, an energy model, that the Department of Energy already used, and he wrote code to create a green roof option in that model. And so he pulled data, and he used 2 scenarios. One was a green roof in Chicago, one was a green roof in Houston, and he compared them. And what he was trying to do was he was trying to say, how many years does it take to get your money back for your green roof based strictly on BTU usage for your HVAC system or your heating system? And his results are pretty interesting, and he found that most of your energy efficiency increases are maximized in the warm season, and they're even more maximized at warmer latitudes, which means Houston, Texas got a lot of bang for their buck. Chicago, on the other hand, they did okay in the summer, but they were either break even or sometimes in the scenario losing energy in the winter. And that makes sense if you think about it, because evaporative cooling is a thing, right? Well, if you have a green roof on a building and there's snow melt, or it's just wet in general, in the wintertime, that wet green roof is actually sucking energy out of your rooftop in the winter. And so the good news is in Chicago and other northern urban climates, the benefits of the stormwater management outweigh whatever you lose in your energy. And in all of his scenarios, the winter loss was made up for in the summer. But you do need to know it's not just a one-size-fits-all general, oh, green roofs are going to make my building so efficient, because it depends. A reduced urban heat island effect, that is to say that a vegetated rooftop is cooler than a non-vegetated rooftop. You're not going to see a noticeable reduced urban heat island effect. You're not going to walk out of your building in the middle of Manhattan and say, wow, it feels so much cooler now that they put that green roof on the building 3 blocks away. You would have to vegetate all of the rooftops. But if we did that, we would see a noticeable decrease in our urban temperature. Noise pollution management. I haven't seen any stateside research done on this. There is some very interesting work that's been done in Japan and China on using green roofs to mitigate noise pollution, both from above, and they've studied placing a green roof. If you have a terraced building where like one floor looks out onto the roof of another floor, if you green that roof, you get a lot less noise pollution from the street. So that's kind of cool. Increased aesthetic, we know that when people can see plants, they are more efficient in their working environments. They are happier, and so that's good. Urban agriculture, that's kind of a new field. The last 2 or 3 years of research, we've seen that done. My strictly opinion, not based on anything other than a few of the papers I've read, my gut tells me you get more of a social benefit from urban agriculture, from rooftop farming, than food production, because the roof access and safety, and we do have some results out of Spain and Sydney, Australia, that show to produce food on a roof, you use way more water and other inputs than if you try to do that traditionally. So I think you get a very measurable social benefit. I don't think it's a sustainable farming practice, though. So what's a green roof? It's a structure with plants growing on it, regardless of the intent, whether those plants were put there on purpose or not. If they're growing on a roof, you can see the roof on the right is arguably an accidental or unintentional green roof. It's still a green roof. History of green roofs. I read this really cool paper back in 2010, and I've quoted it a lot, and people are always surprised to hear this, so I repeat it a lot. Functional green roofs date back to centuries. Scandinavian and Native American tribes, specifically in the Dakotas. Aesthetic green roofs, we always hear the Hanging Gardens of Babylon example. We obviously never saw those, but we know based on written accounts, probably those were very elaborate rooftop gardens. They weren't actually hanging in the sky, they were on the rooftops. Here's some pictures of green roofs. The Hobbit House in New Zealand from Lord of the Rings. There are Native American huts. There are Scandinavian mud huts. These are all green roofs. Modern green roofs. This is the study that I reference now quite a bit. Manfred Kohler published a paper in 2010. He went through all of the historic green roofs in Germany, and I think his limit was 100 years old and older, and there were quite a few that had survived both world wars. And I cite this a lot, and this came directly from this paper, and people are always surprised to hear it. Despite what some German practitioners would have you believe, the first modern green roofs were an accident. No one set out to create a green roof. It happened accidentally, and here's how it happened. And this is from Manfred Kohler's paper. In 1839, a barrel maker invented a way to waterproof a roof. And he did that by combining 4 sheets of paper and tar. Well, once he waterproofed his roof, he wanted to protect the paper from UV light because he knew if it broke down in the sun, he would lose his waterproofing. Makes sense, right? Okay. Well, when you build a building, you usually have to excavate some amount to get the foundation level. So he took that excavation and put it on the top of the on top of the tar paper to protect it from UV light. So that was actually beneficial in two ways. One, he protected his waterproofing layer. Two, he didn't have to haul all that garbage off. Okay, well, decades later, all of these roofs that had rubble and soil on top of them were growing plants. Very happily, these plants had not been managed. They were not put there on purpose. They were obviously not irrigated by hand. They just survived on rainfall. And they were lovely. That's what really started the green roof movement, realizing that these plants could grow on a rooftop without much input. That started the modern industry. And that leads us to standards and guidelines. This is something that I drive home in my classes. There's a distinct difference between a standard and a guideline. A guideline is a recommended but non-mandatory specification. A standard is a mandatory, quantifiable specification that sets the lower limit for acceptable quality for something, whatever that thing may be. The word mandatory implies that there are repercussions for not meeting the standard, and the example I like to use for both of these come from OSHA, because everyone knows OSHA, okay? So OSHA has standards for eyewear, okay, right? So your eyewear in a construction site should be stamped Z87. That means it meets OSHA's limit for eyewear. It's a standard. If you don't meet the standard, you can be fined by OSHA. OSHA also writes guidelines. They write guidelines on heat stress and sun protection. The reason they make it a guideline, which is a recommendation and not a standard, is because OSHA recognizes that, for example, 85 degrees in dry heat in Arizona is very different than 85 degrees in the humid heat of New Orleans. So they can't just say, all right, anything over X degrees means you have to do such and such for your employees so that they are protected against heat stress and heat stroke. They also recognize that different humans handle different levels of heat differently. So OSHA created guidelines. One of those guidelines is if you work in a hot environment and one of your outdoor employees goes on vacation for more than 3 consecutive days, instead of putting them back out in the heat for 12 hours a day immediately when they get back, they should start with half days inside and half days outside and transition slowly to being outside all day. That's a recommendation. If you don't do that, you cannot get fined by OSHA, but OSHA is telling you by not doing this, you're exposing your workers to greater chances of heat stroke. That's the difference between a guideline and a standard. So what does that mean for the green roof industry? This is actually an image of the front page of the FLL. I don't speak German. I'm not going to try to speak German. But the FLL is the German industries, the German landscape industries kind of trade organization. They write the best practices for landscaping. They wrote back in the late 90s the first manual for the design, installation, and maintenance of green roofs. So again, they recognized that green roofs, whether intentional or not, were becoming a thing. And once people figured out they could be a thing, they were starting to do them intentionally. So the landscape industry recognized that this basically was landscaping just a few stories up, and they decided to write a manual, a guideline, a recommendation for how to do this best. The FLL it's pretty comprehensive. It's not all-inclusive, but they give particle size distribution, water holding capacity, pH, all of these guidelines for the substrate. They give guidelines for plant coverage, all sorts of best practices. It's a really good guideline. They never meant it to be adopted worldwide, but since they were the first to do any kind of a manual or best practice for green roofing, they unwittingly developed one of the first worldwide guidelines for green roofs. So municipalities and countries around the world started adopting their guidelines. We go to the ASTM now. The ASTM is a standard. As of a few years ago, there is a subcommittee comprised of civil engineers and practitioners who are writing standards for the green roof industry. Here's my beef with the current subcommittee. Many of those members are civil engineers and private sector practitioners who are selling their own system designs. Now, most of their 14 standards right now revolve around the geotextile fabrics, but there are a few of interest. There are fire tests. The fire test standard is excellent. You got to know that your building is not going to be more susceptible to fire if you have a green roof on it. Saturated water permeability. This is one that I don't think was done very well. Here's why. For saturated water permeability, the ASTM standard says that you need to soak your sample 24 hours before you do the test, right? That's standard. That's an actual soil science and agronomy practice. That's a civil engineering practice. It makes sense that they would have written the standard that way because that's how we test water permeability for medias. That's what we do. Okay, the problem is that gives you a truly saturated media. All of the water sits there for 24 hours and pushes all the oxygen out. Green roofs don't get saturated, not like a lab test. I have data from my dissertation where my green roof platforms were rained on for 72 hours straight during Hurricane Sandy, and my water holding capacity still only maximized at 28%. If you soak a substrate for 24 hours, you're going to every time in the lab get 50% or more water holding capacity. That means we're overestimating how much water our green roofs can hold. So even though these are standards, they may or may not be good depending on which standard it is. The other issue I have is it being a standard indicates that there is some sort of a repercussion if you don't meet the standard. But right now, this is so new in our industry here in the United States. I haven't seen anything happen if you don't meet the standards. LEED. This is neither. LEED is one of the organizations that kind of drives green roofs right now. Leader in Energy and Environmental Design. It's a certification program that's sponsored by the U.S. Green Building Council. And so basically, if you're doing new construction for anything really, new construction, you can fill out hundreds of pages of documentation and show all of the ways that you have been a leader in energy and environmental design. You send that application and a check in to the U.S. Green Building Council. They go through it. They come and look at your building, and if you meet and add up enough points, you can earn silver, gold, or platinum LEED certification. That comes with a bright, shiny plaque that you can hang in your lobby and boast that you are a leader in sustainability because you have met the LEED standard for whatever certification you earned. You can earn points everything from having low emission glazing to only using building materials within a 500-mile radius. There's all sorts of things. It's very comprehensive. Last I checked, you could only get, I think, 6 points for having a green roof, but 6 points can make the difference between no certification or silver and gold. So we often on LEED buildings do see green roofs. But remember, it's not a standard. Here's my unadulterated, honest opinion. It's a money grab. I have yet to see data-based proof of a measurable environmental impact. That is not to say that it's not good, it's just not great. Certifications for LEED buildings can go over $20,000. This is direct from their website. Tell me this is not a money grab. You can also be a LEED certified professional if you pay $400 after you've paid for your membership, plus the cost of the study materials. Are you starting to see a trend? That's not to say it's all bad. It just isn't perfect. They have instilled mindfulness that every action and material does have long-reaching consequences. My beef with LEED is they don't have any performance-based accountability, and I'll tell a short story. When I was an undergrad at Auburn University, we got our first LEED building. Auburn may have more than one at this time, but at the time it was the first one. And that was when I was first getting excited about green roofs, and I was so excited that we were finally going to have a LEED building. And I want to think it was silver or gold. But it was a new construction science building. And one of the things that that building had to make it LEED certified was we didn't have a green roof on it, but all of the downspouts for the building went into this engineered bioretention area adjacent to the building. And so it collected the stormwater in that way, and it kept it on the site. And it was awesome. Okay, well, that lasted for about 6 months. If you've seen bioretention, you know often instead of having wood mulch, it's rocks, because rocks don't float. And if you're going to have a bioretention cell full of water, you don't want all of your mulch to float away. That's kind of a common thing. Well, during football season, I'm assuming during football season, someone saw that and it didn't match the rest of the landscape on campus and they didn't like it. And so not terribly long after, they dug that up, capped it off, and put a traditional landscape back around that building. It was no longer capturing the stormwater. The stormwater was then going into the drain. Now, did anyone from LEED come back 1, 3, 5, 10 years later to see if that building still met the metrics? No. And they got to keep the very expensive plaque that they paid for. That's my problem with LEED. Okay, moving on off of my soapboxes. Green roof classification. So green roofs are typically classified based on the substrate depth. There's a great cross-section of a green roof, and let me turn on my little spotlight here. So here, if you look at the red dot, that's your waterproofing layer. This is a drainage layer. This is kind of an old-timey drainage layer. We're starting to see a shift now towards granular. We've seen some research done now that shows if you have a granular drainage media, you can hold more water and you get better three-dimensional water flow, but these are still used sometimes. The white is a filter fabric. You have to keep all of your media out of your drainage layer because you don't want to clog your drainage layer, because that kind of makes sense, right? Here's your substrate, and then here's your plants. So the depth of that substrate layer is what determines the classification here as either intensive or extensive. And the idea there is that the deeper the substrate, the more maintenance you're going to have to do. So is there a standard or guideline that differentiates between extensive and intensive? No. I pulled this directly from a fantastic review article by Rachel BERNDTSSON. She did a great job reviewing the literature, and she compiled, these are just a few of the examples of differences between how people delineate between intensive and extensive. And it really just depends on the municipality. It depends on the region of the world. But in general, deeper is intensive and shallower is extensive. If you are in the industry or if you are doing research, check with your state stormwater manual. I actually did this search a few weeks ago for my class. All 50 states, even Alaska and Hawaii, have stormwater management protocols at the state level. Sometimes it's their Department of Environment, sometimes it's the Department of Natural Resources. It depends on what the state is, what it's called. But every state now has stormwater management guidelines that have to be met, and most of those include green roof criteria. Even Alabama has green roof criteria now at the state level. That typically is where you're going to find the official delineation for intensive and extensive, and it does matter because, for example, in Maryland, if you break the line between intensive and extensive, you no longer get stormwater management credits for having a green roof. It has to be extensive, not intensive, okay? All right, so there's two options for construction. You can have a modular or a tray system, or you can build it in place. I'm going to talk about each one of these. Modular systems, not a fan. Here's why. The ease of installation is a fallacy because you still need a crane. If you could get away without paying for a crane, I could possibly see the justification. The problem is it's no more or less expensive than a built-in place. Instead of paying your guys to shovel and move substrate around your roof and plant the plants, you're paying them to walk back and forth, placing trays on a roof. It's not any easier or less expensive. Also, with a built-in place system, you're really just paying for the labor, the substrate, and the plants. For a tray system, you have to pay for all of that plus the trays, so it kind of doesn't make sense. If you're looking at it from a sustainability standpoint, think about all of the plastics that were manufactured going into that system and tell me if it's still sustainable. And then it's a maintenance nightmare. Now, This is going to vary based on region, but where I was on the East Coast, we had about 30 freeze-thaw cycles every winter, and that's based on my dissertation data. And what I mean by freeze-thaw cycle is I mean in the winter, the nighttime lows were below freezing, and the winter daytime highs were above freezing. That gives you a single freeze-thaw cycle. All right, so what happens when water freezes? It expands. Okay, so if your green roof media is up there holding any amount of moisture, and in the winter it is typically a little bit wetter, especially there it rains more, you have snow melt. So that substrate expands and it pushes against the sides of the trays. And what happens? It breaks. And you can see the picture on the left, the media has started falling out of that tray along the bottom. In my experience, that corner where the bottom meets the wall of the tray, that's usually where they start cracking. And then one of the selling points that these manufacturers like to use for their systems are, oh, if you ever have to do roof maintenance or change your drains or do anything, it's so easy. You just pick up the tray and move it. Well, that's a load of crap, because I know from personal experience, if you got to pick up that tray, the bottom busts out of it, and then you're still up there with a shovel like you would have been anyway. Please don't do this. The other thing that can happen is these trays break, and that hard plastic turns into shards, and if you're not careful, then if you step wrong on one of those shards, you could feasibly break through the waterproofing membrane layer. It's just please don't do this. If you're in a region where you go through a lot of freeze-thaw cycles in the winter, it's not worth it. The other thing is, they never look quite as good. I was responsible for over 2 million square feet of green roof in my old job. I've seen dozens of tray-based systems. I've seen them from a month after installation to 5 years after installation. The plants never grow over the edges. The salespeople will tell you that they will. I can promise you they don't. Here's why I think it is. Obviously, we'd have to do research, but water has preferential flow, right? So when water hits the edge of the plastic, it's going to immediately flow down into the bottom. That, combined with the fact that there is always an edge effect, means that the edges of the substrate around that tray are always a little bit drier than the center of the tray. And so the plants are going to hang out where there's more moisture. Even though these plants are tolerant of drought, they certainly don't prefer it. So they don't like to grow to the edges. The other thing you've done from a stormwater management perspective is you've broken up the hydrology. There's a lot of research out there that tells us that if you have broken up hydrology, you don't hold as much stormwater. There was a graduate thesis from the University of Georgia and another one from the University of Connecticut. They independently decided to do a study where they compared tray-based to built-in-place systems, and built-in-place holds more stormwater. And if you think about it like this, instead of one 10,000 square foot green roof, you now have 10,000 1 square foot green roofs. Your big area is going to hold more water. Please don't do this. Okay, so here's your starting point if you're going to do a built-in-place system. This is the French Embassy in Washington, D.C. My former employer installed this system. And what you're seeing is a waterproof roof. Now, I've heard people say, well, I don't want to put plants on my roof because it's going to come inside my building. Dude, it rains all the time and water doesn't come in your building, so you're going to have to waterproof it anyway, right? If the waterproofing is done well, then you shouldn't have any problems. Another thing, if you're in the industry or if you're a landscaper and you're considering starting to bet or bid on these jobs to open up your book of business, please have written into your contract or have written into your bid someone to do a certification for the waterproofing membrane before you step foot on that roof. And that means they'll cap off the drains and they'll flood the roof and they'll shoot it with electricity, and there are wires up under the waterproofing, so if there's a leak or a breach in the system, they'll know, one, that it's there, and two, where it is so they can fix it, because the last thing you want is a leaky roof that was leaky before you got on the job, because if you go put a green roof on a roof and something I don't know, penetrates the waterproofing membrane, you're going to get blamed. So it's kind of expensive, but it's worth it to build into your bid to not be responsible for repairing the waterproofing membrane down the road if you didn't do it. Now, if you did it, that's a tough lesson for your employees to learn. Okay, so this is the waterproof roof. Here's that cut section again. Most building codes, and this is especially true in DC, most of those building codes weren't comfortable with having plants grow all the way up to that parapet wall. So all of our roofs had an edge of gravel where plants were not supposed to grow. And then the same thing around, here's a drain box. This is a protective fabric that goes on top of that waterproof membrane just to protect it against anything that could happen. So that pea gravel would go around that drain, and then we would put metal edging that had water holes cut through it so that the water could drain out around there. So that was meant to be a protection against where the waterproofing ended and the flashing began so that roots could not grow in there. Okay, so let's go back out of my pen. All right. So here's how we got the substrate up to the roof. Now, this is a blower truck, and so basically the truck, there's a big hose here that sucks or blows the media up onto the roof. Now, in DC, because green roofs are so popular, it costs about the same to rent a blower truck for a day as it does to rent a small crane for a day. So for us, what dictated this was the French embassy said, no way you're getting a crane onto our property, so we blew it. So we would do either way. Why is my pen not working? Okay. Here you can see those pieces of metal edging with holes cut in them. That was going to go around the parapet and around the drain boxes. And there's the other end of the blower tube where it's blowing media. And then we can talk about various plant installation methods. So plugs, this is not a great picture, but this is a roof right after it was installed, 0 months after installation. Plugs, these prices are probably not exactly accurate anymore, but for us it was about 85 cents a square foot and up, depending on what kinds of plugs we wanted. 6 months later, we're at 80% coverage. Those are not weeds, by the way. Those are spent flower stalks from dianthus. 14 months later, up in the foreground, you can see the dianthus in bloom. The light purple in the back is allium. We're fully covered here, and this is 4 years later. And you can see there are ebbs and flows of species. In wetter years, certain species are more prolific, and then in drier years, other species are more prolific. A mixed community planting is always going to be better so that you don't have, a dry year is going to kill your roof. You need to have various species of sedum. Pros for plugs, it's cheap. Installation requires little to no skill. Anyone can do it, even a Bama fan. Cons, exposed substrate allows wind uplift. Now on that roof, we had a tall 4-foot parapet, so we didn't really have to deal with wind shear. But on some of our city roofs, especially in DC, wind shear was always a terrible problem for us. And then some clients want an immediately 100% covered green roof. We had an architect say, hey, I want a green roof, but I want it to look like one solid plane of plants. He didn't want those mounding broadleaf plants. So we decided to experiment with cuttings. Cuttings 5 months later, 16 months down the road, and it looks like a pretty solid plane of plants. And you can see there's netting on the right side. That's to protect against wind shear. It's jute. It does break down. By the time it breaks down, the plants have grown through it. No big deal. And on the left, you can see that gravel edge around the parapet wall where you're not supposed to have plants growing. Obviously, our maintenance guys had lacked up a little bit there. Pros, faster full coverage. You can get a lawn look easier, but it can get expensive. If you have to buy your cuttings, you're looking at over $10 a square foot. Cons, you're limited to narrow-leaf sedum species. Cuttings can and will blow away, so you either have to use netting or get creative. We were actually able to harvest some of our own roofs. I could harvest my roofs and sell them to my installation division, In that case, I was only paying for labor. He was happy because he was paying less than he would have to order them, and we were doubling our profits. Cuttings and plugs. You can mix those if you want certain species. There we go. Pros there, the plugs are going to help block the wind from blowing the cuttings away, and you can kind of see there, we have plugs planted, and I know what I'm looking for, so I can see it, but in between those plugs, there are cuttings spread on that media. But because you have a little bit of a tall plant planted as a plug, it actually does help protect those cuttings from blowing completely off the roof, and you can see the parapet wall on this roof is quite short. 15 months later, and then the cons, none unless the cost of cuttings proved to be a limiting factor. This became one of our favorite ways to establish green roofs because it was so easy. Pre-grown mat. This is right after installation. I'm not a fan of pre-grown mats, and if you are a horticulturist, you will understand why. These mats are grown in peak nursery conditions. They are fertigated, they are irrigated every day, they are beautiful. I've been to Semper Green's growing facility in Culpeper, Virginia, and I can tell you they are gorgeous out in the field. And then they're cut and rolled up and put out on a roof, and they're grown in coconut coir, which is bad for two reasons. One, there's a high C/N ratio, which means when you put it out on a roof, all of your microbes are going to start working on breaking down that carbon. And since they were fertigated heavily in the nursery, that wasn't a problem. But when you put them out on a green roof where they're not being regularly fertilized anymore, they start showing signs of nursery deficiency. Those big patches of green, those are clovers. Clovers are a sign of nitrogen deficiency because the microbes trying to break down that coconut coir in the media have taken everything away from the plants, and now clover has come in. The other problem that you can get is Phytophthora. The only roof we ever had a Phytophthora problem on was a pre-grown sedum mat. My guess is there was so much organic matter coming in from the nursery. When it went out, it just happened to go out at the end of summer when it was humid and rainy. And just a couple weeks after installation, it rained, I want to think like every day for a week. And then the whole roof just rotted. It just rotted black. And it was Phytophthora that it was introduced from the nursery. The other thing, these pre-grown sedum mats don't like to root in, so you start getting grass and weeds coming in and outcompeting the sedum. You go from a perfect, well-watered condition, and those sedum mats are not hardened off before they harvest them. They go from, we're growing, we're happy, we're irrigating, we're fertigating, to, all right, we're going to roll them up and go put them on a roof that might be 100 degrees and it's not going to be irrigated. What do you think is going to happen? The plants are going to collapse. And then if grass weed seed is introduced, they're going to take off because when the sedum recede from the collapse, they're going to be there. All right, so I'm not a fan. They're expensive and they're very hard to grow in, and they don't ever look as good as they're supposed to. The pros is it's an instant green, and that's why they sell, is you sell to the client like, oh, you have an instant green roof. They're never hardened off. They are often rotten when they arrive to the site. You should only have a 12-hour installation window. You need to treat these things like turf grass. Turf grass needs to go down 12 hours after it's cut in the field. These need to be treated the same way. Often they are not. They almost always end up nutrient deficient because you have a lot of carbon material in that media that it was grown in. And it's the best way to introduce a disease to your roof. They're expensive. They're not worth the cost. Okay, seeds. This is where the research is starting to go. There's a guy in Oregon, and I forget his name. Oh, I just had a mental blackout. He's starting to do some work on establishing green roofs from seeds. And right when I was leaving the company, we were starting to toy around with that as well. Now, hydro seeding, the cost per square foot varies based on the size of the roof. I wouldn't hydro seed for under 10,000 square feet just because by the time you pay for the truck, it's not going to be worth it. However, you can do it yourself with a fertilizer spreader. Pros, you have an almost limitless plant palette. You can buy sedum seeds. You can buy dianthus seeds. All sorts of seeds. I would love in Texas to start playing around with bluebonnets because blue pines like drought. If you hydroseed, you have no risk of wind uplift for that exposed media because it kind of creates a glue and it's going to hold it down. If you hydroseed in February, you should have about 80% coverage by June as long as you have high enough germination percentages. We all know as horticulturists that when plants are grown in their final environment, they typically are healthier and will generally perform better than a plant that gets transplanted. Cons: the client may not like the color of the hydroseed solution, or they might expect an instant green vegetated roof, but it can be cost prohibitive if it's a small roof because you have to pay for the hydroseeder. If you can sow seeds with the fertilizer, you can sow seeds with the fertilizer spreader. You literally just mix the seeds with dry sand. I've done it myself. It's easy. It's very inexpensive. Can't go wrong. I think this is where the industry needs to go in terms of southwestern green roofs where we don't have a sedum pallet. And next week I'll talk about why sedum don't work here. They're not going to work here. We've got to find something else that can work down here when it gets hot. And I think this is the way to do it. We need to start toying around with seeds. So for next week, green roof plant requirements, what makes a plant good for a green roof or not, and I'm going to talk a little bit about the blossoming Texas industry, where I think the plant palette needs to go. Maintenance requirements and approaches to maintenance, and I'm going to harp on, so this week I harped on policies and guidelines and things of that nature. Next week I'm going to harp on policies and policy makers. We're going to talk about the good, the bad, and the ugly. Unfortunately, science doesn't often get communicated into policies. We might have scientific results that are 5, 10 years old, and they still aren't reflected in the policies. The policies are what drive the industry, so you need to know what to look out for as policies are being written in your municipality or as they're being changed. And so I guess, Mung, if you want to start